Good morning, everyone. The project is about line coding. So before going to line coding, why line coding is necessary? We know that computer networks are used for communication purpose. For communication purpose, the building blocks are data and signals. As we know that data can be transmitted directly as 1 zeros. It has to be encoded as signal before it has to be so that it can be transmitted. So line coding is the one which converts a bit that digital data into a bit stream. There are different schemes available under this line coding. They are polar, bipolar, Manchester, unipolar, gray code, and all that. But we did particularly on polar, bipolar, and Manchester. So in polar, the one is in polar it consists of 3 levels: plus V, 0, and minus V. One is encoded as first positive voltage and 0 is encoded as negative voltage. In polar again there are 2 types of encoding, NRZ and RZ. NRZ in the sense means one is encoded as plus V throughout the clock pulse and 0 is encoded as minus V throughout the clock pulse. But in RZ one is encoded as plus V for half the clock pulse and it will return to 0 irrespective of 1 or 0. 0 is encoded as negative voltage for the half clock pulse and it will return to 0 for the next clock pulse, and so on. Every encoding scheme will have its advantages and disadvantages. These are the advantages of polar RZ scheme. Its advantages are it consists of no DC component, but it occupies twice as bandwidth as polar NRZ. Now coming to bipolar, similar to polar, it consists of 3 levels, but it consists of 3 levels: plus V, 0, and minus V. 0 is encoded as 0 itself. 1 is encoded as both positive and negative voltages, but the first coming one will be encoded as plus voltage, and the next coming one will be encoded as inverted to that of first one. So it will be minus V. As you can see here, 1 0 1 0 1. The first one is encoded as plus V. 0 is encoded as 0, and minus 1 is encoded as minus V. So you can see that it is inverted to the previous one. Its advantages are that there is no DC component again, but it cannot correct itself. There is absence of any clocking component for ease of synchronization. Next, coming to bipolar RZ, as I said that RZ for every clock pulse it has to return to 0 at each half clock pulse. So you can see that 1 is encoded as positive voltage for half of the clock pulse and then it is returned to 0. 0 is encoded as 0 and the next one is inverted to that of previous one, but it is encoded up to only half clock pulse and then it is returned to 0 again. These are the advantages and disadvantages of bipolar RZ. Coming to Manchester, it is quite different to that of previous encoding schemes. As you can see, there is no DC component at all. In Manchester, it consists of 3 levels: plus V, 0, and minus V, similar to that of polar, bipolar. But 1 is encoded as first high, then low. 0 is encoded as first low, then high, and so on. The disadvantages of Manchester is that it occupies larger bandwidth due to greater number of transistors are there. Since you can see one has to be encoded 2 times. I mean, plus V and also minus V. 0 contains minus V and plus V. So you can say that there are greater number of transistors. Simulation. We have simulated the polar, bipolar Manchester using Xilinx. The data given is 1 0 1 1 0 1 0 0 and so on. You can see all the results here. This is polar NRZ. 1 is encoded as 1 itself and 0 is encoded as minus V and so on. This is polar return to 0. As you can see that 1 is encoded as positive voltage for half the clock pulse and then it is returned to 0. For 0 it is encoded as negative voltage and after the half clock pulse it is returning to 0 and so on. This is bipolar. This blue color is bipolar NRZ. 1 is encoded as plus V and then 0 is encoded as 0 itself, and the next coming one is inverted as the previous one. You can see here this one and this one are inverted and the next coming one is inverted to this, and so on. This yellow line is bipolar RZ, similar to this only, but half the clock pulse it is returning to 0. 0 is encoded as 0 and the inverting one is minus V for half clock pulse and is returning to 0, and like that. The last one is the Manchester. 1 is encoded as positive voltage for half the clock pulse and then it is encoded as minus negative voltage, and 0 is encoded as first low, then high, and next coming one is encoded as first high, then low, and so on. Thank you.